getting a system like that designed is took a lot of thought for us, because we wanted to target, especially being able to supply the small wind area where we started with these with the ideas, but also being able to scale it up to bigger turbines. So and the thoughts behind making a new online solution were that obviously we needed a very secure system, because you are able to manage and control the wind turbines from abroad. So we needed to be to have an encrypted connection and a fully updated cloud solution. That was obviously number one. To being able to target small wind, it had to be affordable, because the customers of small wind are oftentimes private persons, so they are not always looking at on all details in having a cloud solution and understanding it all. So they at least it need to be affordable, and that means many different things. That means that we can keep it running on our servers. That does not cost a lot, and we can run it of low data consumption, because we are running on a cellular connection for these controllers or these wind turbines. So all aspects of it has to be affordable, and then showing that it adds real value, and by that meaning that we have full control over the turbines, so we are able to troubleshoot from home, so we can eliminate any downtime. That if you have a failed component, and you need it replaced. But an example could be that we have a wind turbine running on with two generators. We could simply disable the one from home and having the visit delayed, so a service team could be in the area. If it's a wind turbine out of warranty, the customer would be paying for that trip, and if that trip can be split into visiting multiple turbines in the area, there's a saved cost. So adding real value for the end customer and for the service companies. Then we are quite a small company, 17 people. So we need to. We wanted to make we want to make a convenient interface, but we actually kept everything as simple as possible with the least possible wording. So if you understand what a kilowatt hour is, and if you understand meters per second and the different values there, then you basically could jump right into our SCADA system and understand it for yourself, and we would not be charging for training and having to make extensive courses on using our system, and we would simply not have the capacity to do so. So that is one of the ideas behind creating the interface that we have. This, what you see up here, is our version 2 releasing shortly. And continued, we due to cost, we need to do fast and easy deployment. So we don't need extensive work to installing a new system in a foreign country. We basically send a SIM card along, and they plug it in, and then it runs. And that is also why choosing a cellular connection could or change what was one of the main ideas for us, because what would happen if we were using the customer's internet connection is that some of the others listening in could agree that that then you suddenly get a call if they forgot to pay their internet bill, or if they changed the router, or in whatever case, and you start being a IT support company instead of supplying what you're good at. So that is why we added the cellular connection. So we have full management over the how the connection is running and how much data is consumed. But it also means that we need to minimize our data stream to not have a very expensive cellular connection. So the system we built is throttling the internet bandwidth. So the controller itself knows if a customer or a service company is logging in to see its data, and then it registers that, and then it speeds up and becomes a live connection. So it's only data consuming at higher rates when a user is online, and then when the user is out, it shuts down, and then it sends data to the database at the speed which is defined. So we need to, as we're coping with, I think we have around 20 to 30 different wind turbine models that our controllers work with. So we needed to define or make a flexible or at least a minimalistic overview of what data comes from a wind turbine. So we could cover all the different models that we are supplying with control systems. So we made a very minimalistic interface, and then we also have the capability, as we do have control of the turbines from it's a two-way connection. We are able to control the wind turbines from rules on our SCADA system. So we can basically set up if you have what's called shadowing on a neighbor's house. We could basically put in the calendar into the SCADA system and tell it when it should shut down, and then we would simply just have a light sensor sitting on the a lumen sensor sitting on the turbine. So we know if shadowing can happen, then we can shut down within these times. So this makes it or at least possible to add functionality without going to a wind turbine and putting in new embedded software to the control system. At the time, it was easy to hit point number 7 in 2014-13, as you saw from the slide or from the agenda. There was basically no competition that we could find. There was one supplier, but they went away with when the company went bankrupt. That had some of the feel of what we were going for. A lot has happened since. I'm seeing comments coming in here. Okay. So it was easy to disrupt this area a little bit with our nowadays other things are coming, but what the customers were used to at this point in time were to have data every minute, and they were not able to control the turbines from their smartphone like we are now. So and obviously we are able to constantly update the system from home, where we have our programmers running working on the servers. We have 2 people running working on systems like this full time, and we continue to develop the interface and obviously do security updates, add new features together with our customers. You know, a very recent thing could be that we have additional work in terms of limiting the wasted hours in servicing wind turbines. So we could add more updated route planning and such forth. Now we gather all the data. We have 1 minute data for the around 1,200 turbines. So we are able to, when we have one model of turbine, we are also able to do predictive maintenance